He was bestowed upon with the prestigious Shanti Swarup Bhatnagar Award in Chemical Sciences in 2000 and Shastra CNR Rao Award in Chemistry and Material Sciences for the year 2014. He is a fellow of the Royal Society of Chemistry, Indian National Science Academy, Indian Academy of Sciences, and National Academy of Sciences. He is J.C. Bose National Fellow of Department of Science and Technology since 2008. He was in the editorial advisory board of the Journal of Physical Chemistry and Sir has guided 40 PhD theses and has published more than 280 papers in international peer-reviewed journals. He has authored a book titled Mathematics in Chemistry and contributed to chapters in several books. He has been invited to deliver plenary, keynote, and highlighted lectures in several institutions and international conferences of repute over the years. Our questions from prestigious schools like DAV Public School, Bhubaneswar, ODM Public School, Bhubaneswar, the Platinum Jubilee High School, Warangal, Ambika Prasad Memorial School, Unnao, the Heritage School, Kolkata, Mahadevi Birla World Academy.
Yeah,
Up to you, sir. You can
no,
speak
no, no,
as
no.
much
Since
as
you
you
have
want.
other people to speak, and I think my own colleague, Professor Jayasri Das Sarma, is also waiting to speak. And, I must also thank her because she connected me to all of you for this particular talk. And she asked me to talk about chemistry, biology interface, or how chemistry and biology is going to revolutionize science. I think that is very important. So I was not very sure that I should make a presentation, because if it is usually goes on presentation, it becomes much longer. If it is shorter, maybe it is easier to speak just extempore. But I have some slides. If it is possible, I will try to show a few slides only. But let me first ask you: are they all science students, right?
Yes, sir. They are all science students.
And which class they are?
11 and 12, sir.
11th. Great. So I think you are at a very important crossroad, my dear friends, young friends, because you are not only going to give class 12, you have to also decide what you want to do. That is a very, very difficult decision. Should you go for medical? Should you go for engineering? Should you go for science? I'm sure all of you are thinking about it. The standard way that people think is either you go for medical, or you go for engineering, or you go for science. However, one thing you should realize, that all these subjects have merging. Whether you do engineering, it has a science component. Whether you do medical, it has a science component. So in fact, today we say engineering science, we say medical science, because everything is in a way science. Any innovation you want to do requires science. Anything that is new that you want to do requires some component of science. So I think without science, you cannot be a good doctor also. If you are only going to become a clinical medical doctor who just treats people and just gives medicine, even such people require science, because very soon they will get outdated. So they have to read the modern discoveries of medicine. Similarly, an engineer has to always keep himself or herself updated with what is happening. So I think the science is there everywhere. So please do not worry whether you go for pure science or applied science. In fact, very early days, I tell you, Louis Pasteur, a very famous French scientist, he said there is there is basic science and its applications. That's all he said. So both of them are very, very important. Because of course, to apply good science, you require to know good science first. You cannot apply good science unless you know good science. So what I'm trying to say is that the science is going to be prevalent because you are a science student. That's very important. And whatever you do, you have to remember this in your life, whether you want to take engineering, want to take medical, you want to take pure science. It's very hard. I myself went through a lot of difficulty in choosing my subject. I'm, of course, a professionally chemist, as you heard, but I did not have been a chemist. I could have been something else, just like many of you have lots of options. I had also a lot of options, and I decided to choose chemistry. Now, in the time that I was, there was only what is called class 11. There was no class 12. I think I don't think any of you will remember, not even Madam Vijay Lakshmi Kumar, you will also not remember. So class 12 had come, by the time you studied. So in my time, it was class 11, I'm talking about 1960s and early 70s. So there was no class 12. So after that, class 12 came. So when I was in class 11, I had similar difficulty, what to do. And I was in a small town in West Bengal, which is actually not a very small town today. It is the second most populated town in West Bengal. I don't know if you know the name. Anybody can tell me which is the second most populated town in West Bengal? Since you're in school. It's a fact. So you go by the latest census. Okay. Anybody can tell? See, this is the problem in West Bengal.
Siliguri?
No. You are just
Asansol?
Durgapur.
Asansol. Asansol is the second largest, Siliguri is the third largest, Durgapur is the fourth largest. Okay, that's how it is. All right, but actually many people don't know. All right, many people don't know this simple statistics because West Bengal is so much dominated by Kolkata. And they thought of Kolkata that nothing else comes. Okay, the rest comes as some afterthought. If somebody has told you, oh, there is Asansol, I did not know. But it's a fact that Asansol is the second largest. So I actually grew up in Asansol, though I was born in Ranchi, which is not very far from Asansol, though. It is currently in Jharkhand. That time it was in Bihar. So I grew up in that part of the country, Asansol, Ranchi. So you can imagine where I am. I was not here, actually, not in Kolkata. And so in the schooling, I did in a reasonably good school in Asansol. It's a Bengali medium school. It was in the state board, West Bengal High Secondary Board. Of course, CBSE, ICSE, convent schools were there even during our times. But we chose to study in mother tongue. And it was actually called Ramakrishna Mission School in Asansol. I think many of you might have heard the name Ramakrishna Mission School, right? So there is one Ramakrishna Mission in Asansol as well. So I studied there. And the school was very serious, I must tell you that. Just like many Ramakrishna missions are. And then I had a problem because from class 7, 8, actually at class 7, 8, and even before, I was very good in Bengali. Many of you may not realize, I was actually very good in Bengali to the point that my teachers told me to take Bengali after class 8, so not even science. In that time, 9, 10, 11, you have to choose science, arts, commerce. Those who would recall. So I was asked to choose arts and take Bengali as my main subject. So I could have been a master's of Bengali and PhD, whatever today, writing novels. So life can be very fascinating. And I was truly very much interested in the Bengali language and the literature. I was fascinated by Tagore. I was fascinated by Satyajit Ray. Those were very, very, Satyajit Ray was very influential during 60s and 70s. The movies, all the great movies which started coming like Charulata and so on in the 60s. I think it was a very exciting time. I always tell that those who have missed the 60s or 70s have missed the last part of the last century. There are fascinating things that are happening all over the world. The French Revolution, Europe, a lot of things were happening. Hippie movement, then the music. So many interesting things were happening that we got excited about doing something very different. So I didn't want to be like normal people, choosing careers. But eventually I went to science. I went to science, again, not because I had a great liking for physics and chemistry, but I was very good in maths. And that's what I always tell. The two subjects I loved in my school was Bengali and mathematics. It's a very rare combination again. And I was very good in maths. And of course, English is something that you learn. I mean, in India, you always learn English, And today, of course, I can't imagine that I wouldn't have learned English properly. I'm speaking everywhere, all over the world. So we learned English, and then we had to find out what to do now in class 11. I never thought, unlike today, where there is so much of coaching, so much of discussion about career, I never thought that I had to think what to do after class 11. And then somebody said, no, now it's time that you have to think. So, of course, I didn't know science or engineering, what I'm going to do. I didn't take biology. So medical was out of my plate at that time. It was between science and engineering. Presidency, I had heard of the name Presidency College. That time it was a college. Today it is university. I had heard about Jadavpur University. Their engineering was very good. So I thought I will give the exam. I had barely heard of IITs. It's very interesting that being in Asansol in 1972, IITs did not have that much of presence. Today, you cannot imagine a kid who has not heard of IITs, right? I mean, at your level, everybody has heard IIT, right? It has become a brand name. We had barely heard IITs, but somebody told me that, look, there are IITs. I said, oh, what is that? Then I came to know a little bit of IITs. There was no Mr. Google at that time. I hope you remember, in 1972, I'm talking up. There was not even internet. Okay? There was barely a telephone. Barely a telephone. Forget about mobile telephone. Barely a telephone, meaning if you want to call somebody outside, you have to go by what is called a trunk call. None of you have heard trunk call. It goes through an operator. You have heard trunk call? Oh, great. So it goes through an operator. And then came the STD much later. Today you heard of STD codes and all that. I saw all that happening in this world. That is the big advantage of living long enough. You've seen a lot of things that happen. So I then decided, okay, I have to sit for the IIT exam. There is only one IIT exam, not JEE mains and JEE advanced. There is just IIT JEE. I sat for the exam. It was very interesting. I did not hear any coaching class. There was no coaching class, not at least in Asansol. So I just sat. I did not have any pressure. Like today, when you go for IIT JEE mains, oh my God, so much of pressure on these children. As if life is, I didn't have any pressure. It was a fun for me, actually. I went and I got admission. Actually, I got ranking. I got very good ranking. I must tell you that. My All India rank was 249. Yeah. Okay, and my Eastern Zone rank was 36. And with that, no, I mean, it's okay. With that, you can get anything that you want in IIT. Including, remember, there was no computer science that time. There was only electrical engineering at IIT Kanpur. I still remember there are only 5 IITs, first of all. There was no sixth IIT, just one. I'm sorry. So at that time, when I went, of course, there are only 5 IITs. So they told me that the Kanpur IIT is very good in electrical engineering. Kharagpur IIT is I still remember this incidentally. Kharagpur IIT is very good in electronics and telecommunication. IIT Bombay was famous for chemical engineering. IIT Delhi textile. IIT Madras mechanical. And I knew that IIT Kharagpur was UNESCO. IIT Kanpur was US funded, PL 480. IIT Bombay was funded by Russia. IIT Delhi, UK. IIT Madras, Germany. I still can tell you. Okay, and you can check those data, the 5 IITs. So I went for the counseling in IIT Kharagpur. Counseling was in IIT Kharagpur, of course, because I was from the Eastern Zone. And my counselor said, you can do whatever you want to do. You are getting everything. What would be your first preference? I changed my first preference. Whatever I had written, I changed there during the counseling because I was getting everything. Then I said, I will do integrated MSc chemistry. That was only the second year that the integrated MSc was introduced at IIT Kanpur. I hope you understand what is integrated masters. It's a 5-year course directly leading to masters. Today, ICARs have BSMS, which is exactly same. But there was no, madam, you are getting impatient. I'll close it quickly. Oh, okay. I thought you are being impatient.
We are absolutely intrigued
Yeah.
and
Okay.
engrossed into your talk, sir.
No. Okay. So thank you. So then I said, look, what am I going to do then? I said, I will do integrated masters. Integrated masters? First of all, counselor said, how did you even hear the course? I said, no, it's there in the advertisement. The courses were listed. I said, do you want to do chemistry? And why? I said, because in my JEE exam, I did worst in chemistry. It was actually a fact. I passed the exam very well, actually. My ranking was good because my maths was good. But my physics, I did very well on that day. I still remember. And chemistry, I somehow managed. And I thought because of chemistry, I will not get JEE. But I eventually got, and chemistry was not so bad. I said, I want to do chemistry. He said, why? Because I did badly. Second is that I am good in physics and maths. So I want to bring in, that is a topic that I want to come. I want to bring in the concepts of physics and maths into chemistry, which I think nobody will be able to do. If you are a chemist doing chemistry, it is one thing. If you are a mathematician doing chemistry, you'll have a different way of looking into it. Actually, I was 17, 17, okay? Just like your age. And my counselor was very impressed. He said, yeah, I mean, that time this talk of interdisciplinary science, today you are saying chemistry, biology, interface, all this was not there. Again, I'm talking of 1972. Please do not forget. I was talking of the days when Rod Laver was still playing, Roy Emerson, Fred Strahl. I don't know if you have followed tennis. They were still batting. Sunil Gavaskar won for India against West Indies, the first series. I hope I remember what I'm talking about. Okay, 1971. I was a very great sports fan, so I can relate everything from the sports, which year, what happened. I'm sure all of you are, many of you are. So those are the days when I was talking of interdisciplinarity, and actually I applied that to myself. I took chemistry. And it was very hard for me to convince the counselor. They usually are used to thinking that toppers will always take engineering. All right? But that was the beginning of the integrated masters. When I went to Kanpur, I was actually surprised. All India 6th, believe me, was my classmate. He had taken mathematics. I thought I'm the only guy who is trying to be smart. Huh? Then there was my very good friend who was among the around 100. He was physics. So there are and there are another 2-3 good guys who are in chemistry. So out of 11 or 12 people who are doing integrated masters, chemistry, physics, very few people are there. All of them were ranked high. Very high ranked people also took engineering. But those who took science, they were also very high. So that is where my journey started in being a chemist. So I'm labeled chemist. But I had an interdisciplinary thought because I was good in physics and maths. And then later on, when I started doing my PhD, the chemistry started changing. And today, when I look at, Professor Jayasri Das Sarma will speak later, I find there is so much of biology in chemistry, which I never learned in school, actually. So what do I do today? I learn biology. So you keep learning all your life. Today, 1972, I was 17. So you can make out what is my age. I will not tell you. It's a very simple arithmetic. So the question is that I keep learning at this age. Because if I don't learn biology, Jayasri Das Sarma will not respect me. Right? So to gain her respect, I have to learn biology. Correct? And of course, I realize chemists can do a lot of biology. Today, when you talk of drug, it's a molecule which works in our biological system. Right? So the system is biology, but don't forget the drug is a chemistry. Whatever you are taking, a paracetamol, for example, is a molecule. Molecule has a formula. Unfortunately, the school chemistry is very badly neglected. I don't know how many of you like chemistry, but my bet is that most of you don't like. That's my bet. Though I'm not sure. I did not like. I already told you. Most of the people like physics and biology today. You know why? It's very interesting because physics and biology are very different. They require different faculties of mind, right? Physics is more analytical, so you require mathematics. Biology, they think, is less analytical, which is not true actually today. But the point that I'm trying to say that you don't like chemistry simply because school, we don't know how to teach chemistry. This is a glass of water. How do I know that this consists of molecules which has two hydrogen atom and oxygen atom? You are telling me I believe, right? But if I have this pad, I drop it, it falls. I see that. I see the Newtonian law every day. I watch cricket, I watch tennis. How do I see chemistry? How do I know this has how many molecules of water? Oh, you have to learn Avogadro number, blah, blah, blah. Okay? Somebody told you, so you learned. But you can't experience. Biology, you experience. Human beings, yourself, plants, animals. So the education of chemistry is extremely complex. It has its own languages. It has its own syntax, which simply cannot be given. Biology, on the other hand, works at a very macro level, where you don't worry about the syntaxes. But you forget at the end that all of biology that you're talking of is eventually molecules. Your membrane, lipids, skin, everything, blood, everything that you think of is eventually molecules. So the chemistry is kind of underlying in entire system, in the physical systems, materials, in the biological systems, everywhere. So today when I call it a material, so this is a pencil, which is also a molecule. This is a water, which is also a molecule. But there's a difference. That pencil is a hard substance. This water is not a hard substance. So that's how the phases of matter come, right? Solid, liquid, gas. But all of these are molecules. So biology has what is called soft matter. Matter which is not so hard, but it has a molecule. Much later, people started understanding that the chemists understood that they can contribute to biology. Biologists understood, I understood biology, but I could now do much better if I understand chemistry. Then the chemist and biology started getting together. In my life, when I became, after my PhD, I went to National Chemical Laboratory in Pune. It was a chemistry lab. So I grew up in Pune, incidentally. After that, from my age of 20, I did PhD in Calcutta, essentially 5 years. That was the only time I stayed in Calcutta, except for now, when I'm director of IISA Kolkata. The rest of the time, so 1982, December, I actually left Kolkata after PhD. I went to Pune and stayed there for 33 years, retired there as a director. Then I was at IIT Bombay for some more time, 2.5 years before that, after which I came here. So that's another story. But the point that I'm saying, when I went to NCL, by that time I saw the chemistry moving. And it is a national laboratory. I found that biology, you have to learn biology. But nobody taught me biology in school, so you learn on the job. That's what we call learning on the job. You have to learn on the job. And you start to think of chemistry and biology as a subject which can together bring peace, safety, health in this world. Look at today's COVID. What will give you solution? You talk of vaccine, you talk of drug. Vaccine is more of biology. But if you call it post-COVID drug, it has to have chemistry-biology interface. And today, I think we have understood that, how much both chemistry and biology are extremely important. So what I'm trying to say, this interdisciplinary thought is very, very crucial today. So do not think I'm a chemist, I'm a physicist, I'm a mathematician. Everything will be required for a solution. What you require today is a solution. Don't forget, solution to a problem. Think of a problem. And no problem of standing problem, which is a difficult problem, can be solved by one discipline. What are the problems? Renewable energy. I hope you have heard this word, renewable energy. Sustainable energy. Energy which is not going, sources which are not going to be depleted. Think of sunlight. Can you convert sunlight to electricity? Then I don't need the normal electricity. Sunlight is plenty, but how do you convert them? It's not very easy. Sunlight will fall on something. I have slides to show that, and then electricity will be generated. So there will be some coating material on the window which will convert sunlight to electricity. That is a very fundamental work which will require chemistry, which will require physics, which will require engineering, whether you have to make a device. First, you have to find a molecule which will convert. There will be some physics will be there, how sun heat is getting transformed to electrical energy. How will you do that transform? There has to be a molecule. Then you have to make a device. It's a brilliant example of physics, chemistry, engineering coming together. Think of artificial photosynthesis. It is an example of chemistry, biology, engineering. No, those are problems. We hardly solve problems as in Indians. And I'm telling you this on your face. As Indians, we are very good in solving puzzles. So you see, oh, somebody has got Olympiad gold medal. We are very good in solving puzzles. What are puzzles? I give you a puzzle. 1 minus 1, plus 1 minus 1, plus 1 minus 1, plus 1 minus 1, plus 1 minus 1 to infinity. That's a puzzle. So that, what would be the answer? Okay, you can think. I mean, don't say 0 or 1. That's not correct. So you can find out with S shifting to S equal to 1, you'll get S equal to half. Okay, you do that in your school, or how to do a series summation. So the point that I'm trying to say, that's a puzzle. I'll give you 2 buckets of water. Okay, 5 liter and a 7 liter. Very easy puzzle. 5 liter and 7 liter. No other measuring instrument. So you will not know half of 5 liter. You will not know half of 7 liter. You have only those 2 buckets. With those 2 buckets, I want you to measure out every single volume from 1 to 12. 12 is easy, fill both of them, 7 plus 5. But you can, by the arithmetic of 7 and 5, you can actually get 1 to 12. So for example, 7 liter bucket, you pour out to the 5 liter bucket, what remains is 7 minus 5, right? 2. So like that, you can continue to build 1 to 12. Please do that. It's a puzzle. I'm not going to solve this puzzle. What I'm trying to say, we solve these puzzles in schools and we think we are great. Now, see, I'm getting so many marks in maths. I'm very great. But that doesn't help. When you solve problems, that's not going to help. A problem solution is going to require multiple disciplines. And we end up saying that this is what I know, I have solved, now it's your problem. The problem doesn't get solved. On the other hand, in many good countries, people come together. They try to work together. And working together, they can solve problems. Everybody cannot be good in all disciplines. The question is, there's a culture. There is a minimum knowledge required of different disciplines. Getting that culture of working together is a very important part of problem solution. Unfortunately, we don't learn that. We don't learn that in school. We don't learn that in college. We don't learn that in universities. Working together. As you grow older and older, I see with a lot of pain that we learn how not to work together. I say that with a lot of pain. I hope you understand what I mean. As I've grown older, it should have been the reverse. So that's a very important training in science. It's not enough to know. How do you distribute that? How do you distribute that? How do you impact people? How do you impact society? I gave one example. I can give you another example. Your building. The building that you are sitting right now, is it a smart building? So let me tell you what is a smart building. A smart building is a building which will correct itself. So let's say there is some problem in the building. The rain water is seeping. And that's a very common problem in India. Many of the buildings are badly constructed, rainwater starts seeping. What do? You call an engineer. Engineer may come. The principal of the school will call the engineer. Engineer may come after 7 days. They will bring some workers. It will take 3 months to solve it. Right? Simple seepage of water. Okay, and you suffer. Imagine a smart building. On the other hand, it corrects. It not only identifies there is a seepage, it corrects itself. You may think, oh, that's not possible. Yes, that is possible. That is what is called smart materials. That it will identify that there is a problem. That is called sensing. I hope you have heard sensor. The word sensor, you use it all the time. It will sense that there is a seepage somewhere, and then it will correct. Actuation. How is it possible? It must be possible by very smart sensing device, first of all. And then it must bring molecules, it must bring chemicals to that place and fill it. Whatever, good engineering, good physics, good chemistry. Now, lest you think I'm faking, such buildings already exist in the world. And buildings like this will come up. Imagine things. Cars running on hydrogen. Another example, hydrogen-powered car, fuel cell. You might have heard the name fuel cell. Is again a source of renewable energy. With hydrogen is cheap. You can get it, but the most important is that your gravimetric energy that you get from hydrogen is very high. And hydrogen burns, does not give you carbon dioxide. It gives you water. That's chemistry. H2 plus O2, right? Gives you water. So hydrogen is a clean fuel. People are tending towards hydrogen now as a fuel. But hydrogen has a lot of problems because it's very unsafe. So how to handle hydrogen? That's the problem. The point is people are today working towards that. I have in 2012, I remember I was in London, in Piccadilly, they had a demo bus running on hydrogen powered bus, fuel cell bus. So things are happening all over the world for solutions. Bioenergy, for example, from bio waste to fuel. You have a lot of bio waste. How do you harness that to fuel? Chemicals. So I think those are problems you will realize at the school level that it is not biology, it is not chemistry, it is not physics, it is not mathematics. You may be very good in mathematics, doesn't help. Solution of the problem requires several disciplines. So remember this when you are going to choose your subject. Unfortunately, you still have to choose a subject. Because you may now say, why should I choose any subject? Because if every subject will be required for solution of problems, I'll keep my options open all the time. Unfortunately, that is not possible. Because in education, everybody cannot be master of everything. Right? So you have to learn certain subjects much more deeply than the other. So I think that is a very important parameter that you have to remember. Today, there is a very important buzzword called innovation. Have you heard of this word, innovation? I-N-N-O-V-A-T-I-O-N. Everybody talks of it. Can somebody tell me what is innovation? What do you understand out of innovation?
So is it students, any of you can
something new out of creativity.
Something
Out of creativity.
Inquisitivity.
Creativity.
New idea.
Creativity. Then what is invention? Am I confusing? What is I thought invention is that discovery.
So innovation is like a new idea.
I
No,
believe
new idea. that is fine, but invention is also a new idea. I'm saying people already had a word called invention or discovery. I hope all of you heard. Isaac Newton discovered, Archimedes discovered.
Sir, I
Why
think
is only-
innovation. Sir, I think innovation is something like you have an existing thing and you are trying to improve on that.
Build upon it.
that is one type of innovation, no doubt. But yeah, let me try to answer this question. It's not very easy because suddenly in the 2000 and all that we started hearing innovation, and everybody's saying innovation. But there is a technical definition, differentiation between invention and innovation. Invention is you gather knowledge from nature. Nature can be funding organization like Department of Science and Technology who gives you fund for research. It can be an apple falling that Isaac Newton saw. Convert that natural resources to knowledge. That is called invention. Nature to knowledge. Okay, so you understand that first. Innovation is exactly the reverse process. Can you go from the knowledge, give it back to the society, give it back to the market, give it back to the nature? So if you have not giving it back to this, you cannot call it innovation. So if it is only an idea which is not translatable, which is not translated, it is not an innovation. It only remains an invention. Most of us, we don't understand, so we only end up inventing at the most. Even that we don't do. At the most, we hardly innovate. When you innovate, we take some pre-existing knowledge and try to do something, as you said, repair, improve. That is what we call jugaad. Have you heard of jugaad? Yes. Correct? I call that jugaad. We are very good in jugaad. If you go to India, various places in India, we are expert in innovation. But these are what is called low-tech innovation. That is Edison quadrant. I always show that as an Edison quadrant. I hope you have heard Thomas Alva Edison. Lights, Edison quadrant. What is a high knowledge invention quadrant? Niels Bohr. Just a name. Yeah, it could be Einstein, it could be Schrodinger, Niels Bohr. What we need is invention and innovate. I and I, both eyes. Who is that? Louis Pasteur. You are here, low. High, low knowledge, high application. That's Edison. You go here, you have Bohr. You come here, high. That is Pasteur. So we must come from here to go to Pasteur quadrant. That's the 4 quadrants. Very nice, actually. I have a slide, I think, if I can't show you. But how to go to Pasteur quadrant? That's the most difficult thing. You require high knowledge, high innovation. That is what is today called deep innovation. I don't know if you have heard this, DEEP. DEEP, deep innovation. Many people are talking, all the tech sectors, those who have startup companies, these, you ask them, they all want to do deep innovation because that is missing. Deep innovation is not jugaad. Deep innovation is innovating something, that means giving it back to society based on a high fundamental knowledge. That is very, very difficult. So I think those are things that have to be learned. Please read books on innovation. There are fantastic books on innovation, how to innovate. I mean, we of course read books on discovery, good pay publications. I think you know what are the best discoveries. Can you tell me one discovery which you are excited? Any one of you? Yes.
Wheel.
Wheel. Okay, very good. Can you tell one name who discovered some very important principles which you are excited?
So Nikola Tesla.
Nikola
Tesla.
Tesla. Very good. Tesla.
Sir, I love
Sir
Schrodinger's
Martin
cat.
Cooper.
Sir, I love Schrodinger's cat.
Very good. That's still very young. Can you go much older?
Sir,
Martin Cooper's telescope.
Maxwell, James Clerk Maxwell. Great.
Sir Charles Babbage.
Isaac Newton.
Sir Charles
Galileo.
Galileo.
Charles
Sir,
Can we go
Babbage.
back to Copernicus?
Copernicus, Archimedes.
Yes,
So
sir.
Hippocrates.
I hope you heard Archimedes.
The
Yes,
planet
sir.
first.
Yes, sir.
Yes, sir.
Get to play you.
Yeah, do you know how did he discover Archimedes?
Yes.
While
Yes,
bathing.
sir.
By
He was
accident.
in a bath while
Bathroom,
bathing.
but you know what
Yes, sir.
happened? What is the background?
So you
The background is that he was challenged by his king.
Yes.
Find out if his goldsmith is cheating.
Yes, sir.
And those days, just remember, those days the kings are very dangerous. Had he not
Yes, sir.
invented, he might have lost his life. He was worried. So it was an invention driven by the need, driven by the necessity. He had to invent. Imagine, none of us are in that situation. That if I don't invent, I'll get killed. Archimedes had that fear, and when he invented, he became so excited. Not just because of the discovery, because he saved his life. Eureka, eureka. He ran down the streets. There are discoveries which people say come in dreams. Can you tell me one discovery?
Benzene ring
Yeah, that's
structure.
chemistry. That's why I love it. That's chemistry. Benzene. Yeah, Fred Kekule. He dreamed that of snakes singing its own tail. That's a story. Of course, we don't know Kekule whether I cannot meet Kekule and ask him now. Okay, but Kekule dreamed benzene ring structure. So you don't know how inventions will come. Of course, most people say inventions come out of curiosity. Yes, Isaac Newton, brilliant example. He started thinking, why is apple falling? Have you ever thought apples must be falling all over since the beginning of the universe, right? Falling downwards. How come nobody noticed it? Obviously, people noticed it also. But did they not think? Oh, some people must have thought. What was great about Newton? Newton not only noticed it, Newton started thinking about it, Newton found a solution. The Newton's laws of motion. That is a classic example of a curiosity-driven. So I talked of necessity-driven, I talked of dreams, driving innovation, invention. These are all invention, remember. Knowledge, gaining knowledge. Can you think of accident-driven knowledge?
Sir, X-rays. Discovery of
Penicillin?
X-rays.
Penicillin. There was very famous organic.
Magnetism by Oersted.
Yeah, there is a very famous microorganism which was found by a Dutch lens grinder. He was a lens grinder. He didn't want to do biology, but he found something very small from this very high lens, and then that started microorganism. Urea. The most important is synthesis of urea.
Yes, sir. Voller.
Urea, Frederick Wohler, so he synthesized accidentally. So I'm saying you can come on the history of science. History of science is very exciting. The point that I'm trying to say, there is no unique path to discovery. Many people come and ask, oh, how do I get Nobel Prize? I tell them, if I would have known, I would have first got it. Right? Why should I tell you? Obviously, I don't know how to get Nobel Prize. The point is that you don't know how the discovery will come. You have to keep your, what you call, pancha indriya, right? Panchendriya, alert. And then you don't know how things will happen. If I say I am a chemist, I don't understand biology, I may miss something. Or a biologist will miss something, doesn't understand chemistry or physics. For example, I actually profess chemistry, within chemistry, an area called the computational chemistry. In fact, there is a very glorified word called quantum chemistry. I hope all of you have heard quantum mechanics. Application of quantum mechanics to chemistry is quantum chemistry. So I'm more of a physicist. Because I do computation, I'm a mathematics people, I'm a computer science person. But I have to write my own programs. My original training has been to write programs in my PhD. So I'm a very different kind of chemist. Am I not a chemist? I'm a chemist. I got a degree in chemistry. But I am not working in the lab. I'm working in the computer. And then I realized, oh my God, people will not think of me as a proper chemist. Today, all of chemistry people are applying that. They first do in the computer, find out if it is possible to do, then they go to the lab. Biology is benefiting so much about computation, what is called computational biology. So it is an amazing thing that is happening between biology, chemistry, mathematics, computer science, all together. So because of the fact that I'm a computer science, I see the integration of all subjects. The methods that I use are applied to engineering because they are mathematics, metrics, solution of algebraic equations. We have to do that. So I get confused, what am I? So when I'm introduced as a chemist, I'm not sure. I have a degree in chemistry, but am I a conventional chemist? Probably not. So what I'm trying to say today, what will click? You have no idea, and everybody will find their own way. So the life is very, very exciting. You should not be stressed about what career you have taken. You should not say, my God, I took BSc, my life is gone. You may end up doing much more than an engineer or a doctor. If you are good, if you keep your panchendriyas on. That is very, very important. You know, very famous story of Michael Faraday. Have you heard of Michael Faraday? Very, very, one of the greatest. You know, he was contracted by who? You know, Humphrey Davy.
Yes, sir.
Have you heard of Humphrey Davy?
Yes, sir.
Yes, sir.
Yeah, Humphrey Davy had a glass washer who used to clean his lab. He left suddenly. 15 days before, Michael Faraday had come to him after masters. I need a job. Humphrey Davy said, I don't have a job. Davy was very famous. I don't have a job. You give me your phone number. After that, Davy's glass washer left. Then Davy called Michael Faraday. Would you join my lab as a chief glass washer? Can you imagine? How many of you will join like that? Michael Faraday joined Humphrey Davy's lab as a chief glass washer. That is his designation. While he was working as a chief glass washer, he discovered 2 new chlorides of carbon. After that, what did Michael Faraday do? I don't have to tell you. Not electrolysis, physics, electromagnetism. What did Michael Faraday not do? But his first designation was to clean the lab of Humphrey Davy. But because of his job profile, his invention, ability to understand, innovate did not get spoiled. He continued to do that. So your job profile, your education is extremely important. But remember, your going forward will only depend on you and your interaction with the surroundings, your interaction with the human beings, your ability to impact, your desire to impact. Through combination of knowledge, and you have to learn. Today also I keep learning at this age. We will all remain a student. Do not complain that you are a student, I am a teacher. I am also a student. Please trust me when I say this. You will learn much more when you teach. Please try your juniors, class 7, class 8, class 9, mathematics. You will see, you will learn very fast. I'm telling you. When you're a student, something happens because of pressure that your mind stops. When you're a teacher, you have to know, my God, this girl will come or this boy will come. I have to impress. I cannot say I don't know. I have to impress. You learn. I learned much more of quantum mechanics when I became a teacher than when I was a student at IIT Kanpur. IIT Kanpur is a great place. You know, we are taught first chemistry by Professor C.N.R. Rao, whom you might have heard his name, Bharat Ratna. Professor C.N.R. Rao is a great chemist. He was my teacher, actually. First chemistry course. Professor Govardhan Mehta, Professor P.T. Narasimhan, Professor M.V. George, almost all who's who of chemistry were at IIT Kanpur. Not for nothing I chose MSc chemistry at IIT Kanpur. Of course, now you know. I had something in my mind of saying I will do integrated masters of chemistry. because IIT Kanpur had great teachers. I value them. But the point that I'm trying to say that when you start teaching myself, I think even despite that, when I started teaching myself quantum mechanics, I learned faster. So remember this, all your life, this teacher-student symbiosis should continue. Teacher, student, and researcher. Thread them together, you will be doing very good. I think I have taken far too long a time than I was given. So I will probably close. I just thought, if I could say something. Can I make a presentation quickly?
Yes, sir.
Yeah, just present your entire screen, blah, blah, blah. Yeah, these are all new things that we are learning. Remember, digital tools, huh? Nobody told me. When I was a teacher, I used to do in Blackboard. Now we are all learning. So, 1 minute. Can you see this?
Yes, sir, we can.
Can you see this?
Yes, sir, we are able to see.
It doesn't matter. So, yeah, by modeling all this, you forget it. Theory, application. Just 1 minute. Yeah, can you see this?
Yes, sir.
Yes, sir.
Okay, good.
Yes, sir.
Yeah, these are all slides that I will not show, of course. These are the 3 cities. It's very interesting for me to see those 3 cities. It's a trilogy, the 3 cities where I have lived my career. Pune, Mumbai, Kolkata now. Okay. They're very typical. Pune is a city of Vadas, those who know Sambhaji Vada, Shivaji, and basically it's a Peshwa. Peshwa city. Okay.
Shaniwar.
Yes.
All right. Then these are ICERs. This is ICER Kolkata. Those who have not come, blah, blah, blah. Yeah, I just told you what is the fundamental science. I was talking about necessity, accident. Yeah, this is what I wanted to show you. So this is the knowledge y-axis. The x-axis is consideration of use. So this is where we are today. Neither good in great invention nor good in innovation. This is the pure research. This is where we want to come, pasture quadrant. This is only high application, low knowledge. So this is a very important part. How do you come to the pasture quadrant? So I think, I will stop. I don't want to show this. But this is something that I told, that chemistry, physics, biology, there is no instinctive knowledge in chemistry to start with. So chemistry looks very complex. Whereas physics and biology, you can feel. So chemistry has been taught mostly by transfer of knowledge. So I don't want to go into this. If there is anything interesting, I will just say that this traditional barrier of discipline has to be broken, even within chemistry. Chemistry itself is changing. And there is a hierarchy of science which is completely gone today. That many people think that mathematics, physics is built on mathematics, chemistry and physics, biology and chemistry, psychology and biology, but it's very complicated. All right, I will stop here. I didn't want to talk about it. This is what I said, that I'm doing computational science, which is an integrator for finding a solution. Okay, I didn't want to show slides because that's just many for you. So I've stopped sharing. I think I would like to take any questions that you have instead of going through that, because it's already an hour. I could not imagine. I told Jayasri Das Sarma that I just talk extempore, so maybe it will be 10 minutes, 15 minutes. I don't know what to talk. I said, if I start, then it takes long time. But I know that I can give extempore talks for 2.5, 3 hours. I've done that. So that's why I told Madam, it's very dangerous that you are asking me to talk for 15 minutes.
Thank you so much, sir.
15 minutes, you can ask me to introduce myself.
Thank you so much. Questions we would be taking after both the other 2 speakers have finished talking.
Okay.
So over to you, Sharni ma'am. We would request you, sir, if you can kindly stay back for some time and answer, because I can well understand that all these young researchers have a lot of questions.
So what I will do, I will be here, but I will do some other work.
Right, sir. Perfect.
But I will be able to, if there is a problem, anybody can call me.
Sure, sir.
Yeah, but I am here, so you'll be able to see me.
Certainly, sir. Thank you. Over to you, Sharni ma'am. Thank you so much, sir.
Thank you, sir. Thank you, sir, for sharing all your experiences. It was really engrossing. Now I would like to call our headmistress, ma'am, Simran Sanghera, ma'am, to please come and, say some words. Thank you. Simran ma'am, over to you.
Thank you, Sarini. A very good afternoon to everyone present here on this bright afternoon. At the very outset, I take the opportunity to thank Professor Sourav Pal for sharing such enriching words and for his valuable guidance to the students. I think not only the students, but even the parents and the teachers and all of us have got enlightened today by hearing what he said. It was indeed informative and very beautifully he amalgamated not only science, not only chemical sciences or biology, but also about collaborative working. And I think that's the main life skill that every child needs to hone. And even the employees, all of us as teachers, we need to hone collaborative learning. So thank you, sir. It was indeed an honor and a pleasure to hear you talk and share your wonderful, glorious experience with us. Thank you.
Thank you. Yeah.
Taking today's session forward, I believe the key to bright future in this founding discipline of chemistry is to look ahead and to anticipate future developments and adapt to the changing surroundings. Chemical sciences will be increasingly required to solve challenges in health, energy, climate change, water production, and food production. Living in COVID times, the most important aspect of chemical sciences is undoubtedly the advances in personalized medicine, mutational drugs and sequencing vaccines to deal with global health issues, and treatments linked to aging population being the most integral developments of chemical sciences, which is certainly going to be, going to open a wide plethora of options for our youth. So with this little snippet, I am pleased to invite our next speaker for this afternoon, Mrs. Apala Chakrabarti. Madam is recently working as the principal and director at Future Scholars Academy. She started her career as a lecturer at Barasat Government College as a chemistry lecturer around 25 years ago. She has received numerous awards and accolades during her tenure, and to name a few, she received the National Award for Teaching by the Honorable CBSE recently. She has also received the Award for Innovative Teaching by Indian Chamber of Commerce and ABP, Award for Science Drama by the Government of West Bengal, and the list is endless. She was also invited by NASA and National Space Society USA to take part in the International Conference on Space Settlement Program at the St. Louis, Missouri, USA. She's currently working with Development of Science and Technology, Government of India, on popularizing science and motivating students towards innovation. Not only this, Madam has also contributed by writing articles on societal issues and general well-being. I mean, I can go on and on with ma'am's accolades and contributions towards the society. So without further ado, I would like to hear it from Madam herself. May I please invite Mrs. Apala Chakraborty to come on the virtual platform and share her wide experience and guide the students further. Madam, I would request you, please.
Yeah. Well, thank you, madam, for this introduction and all, but I'll not take much time. I have seen after Professor Pal, actually, Department of Chemistry, sir, really means it is very knowledge-gaining portion from your side also. I'm also a chemistry background, and I have completed my research work also.
I think I met you.
Yeah, sir, several times. Several times met in that way. So I'm just, as still I'm working with the student community. So on behalf of the student, the demands and all, accordingly, I'm presenting my chemistry prospect in future. What is their actual question that we understand?
Good. Very good.
Related to that only, I'm trying to explain in short through my short presentation. Okay.
Very good.
In the meantime, I must inform the audience that the questions from the Heritage School, Kolkata, DPS Ruby Park, DAV Taratala, DAV Anant Vihar, Kalyani Public School, Nadia have already been forwarded to ma'am.
Yeah, see, hope that after completion of this, maybe they will be aware of that.
Yes, ma'am. Thank you.
So my screen is visible?
Yes, ma'am, it is.
Yeah. So actually today's topic, prospect of chemical science and research, correct? So first of all, that if the students, you have a particular interest, then only you please select your subject chemistry, then you come to this chemical science in the field of research. And as per Professor Pal, really, whenever it is a subject chemistry, now up to 12, it is limited to chemistry. After that, you will see that this chemistry also is have a lots of branches, and then it is all interdisciplinary. So we cannot confine only in the chemistry part. So then also, as per your level, you can understand the subject is chemistry, physics, chemistry, mathematics, biology, PCMB. So some are the examples where the diverse research here, actually the chemistry experts that they do normally. That is, you are very much familiar with the medicine discovery, vaccination due to this COVID. These are very, very much familiar. Then a most important area, that is forensic analysis, then cosmetics department, environmental issues, lots and lots of areas are there. So at a glance, just for your ground level, I want to say from your side, these chemistries are having lots of branches, but we can add that we can come with our real life experience, like which area these real life experiences are coming, like organic chemistry, inorganic chemistry, physical chemistry, analytical chemistry, biomedical chemistry, environmental chemistry, industrial chemistry, polymer chemistry, lots. Then nuclear chemistry, geochemistry, so many portions are there. I'm trying to give you a little bit idea which are the areas, and normally we tell what is the function of these chemists in the different area where they are working. The analytical chemist, it is they are only with their, who are the analytical chemist, actually with the skill and expertise, they analyze substances, they identify the different components present in what quantities these are present. All these are more or less, these are function of that normally analytical chemist. Here I'm saying that I'm also specialized in inorganic chemistry but I completed my research work in the area of analytical chemist. My research, that is thesis, was synthesis and characterization of new organic reagents and spectrophotometric determination of metal ions. So to work on this part, what I had to do, I had to prepare two organic reagents, new organic reagents. So, I'm inorganic specialized in master degree. Then I come into the analytical side for the research work. Now, when I started my research work, then I had to prepare the organic reagent. That is organic chemistry, as you tell. So then with the help of this reagent, then I analyzed some food items, some medicines, some alloys. These were my definitely this area, that is my research area. So you can understand it is interdisciplinary, all are connected. There is no such specific area so that you can be there. Now you come here, this is I'm showing that now ongoing research. Currently these research are going on in all over the world. So why this is a new research? Combining two analytical techniques brings a new sensitivity for identifying and examining the structure of small molecules. This is a current research, and these have been done by a research group in Netherlands. This is going on. What they are doing? They are doing with new, which is the research, means the new part, that is the technique. The technique called infrared ion spectroscopy. IRIS, they are utilizing this infrared ion spectroscopy to find out the structure of small molecules. This is one kind of analytical chemist work. Then, chemical engineer is also part of that chemistry. So you are saying this chemical engineer is not that kind of mechanical engineer and all, but chemical engineer, it is also branch of chemistry where they, when completing their degree in chemical engineering, so they involve in the design, development of the new products from raw materials, etc., etc. They are preparing, like for example, making plastic from oil. These are the function of the chemical engineers. Now the current, that what I'm saying, I'm giving you the what is going on in all over world, what the chemical engineers research, this is one, this is going on, a promising route for converting carbon dioxide from fossil fuels into useful products. Now the group of chemical engineers, they are researcher. They are doing this work. All of you know that carbon dioxide, greenhouse gas, and pollution, etc., etc. So they are using what they are doing the research in means area. They are using electro-reduction process that is environment friendly. What they are doing in this process, they are achieving that everyday temperature and atmospheric pressure. These are only helping them, and they are using this electro-reduction process. This is the area of research under chemical engineer. Now, this is another one, forensic scientist. They are also chemist. Chemist means they are working on this with the help of chemistry. What they are, I think from the name you can understand that forensic laboratory, it is a very well-known familiar word. So they use that the blood, another then fluid, hair, non-biological substance such as etc., etc. Only they analyze, they do it on this work. So this is a forensic scientist. So forensic scientists, sometimes they may call to the court for any criminal cases and all. Now this area has developed a lot. This forensic scientist, the research area, currently this work is going on all over the world. Vapor sampling nose for sniffing cargo forensic chemistry. This is that what they are working on that, like sometimes previously the forensic they are taking the blood, they are taking some hair, they are taking something, and they are analyzing the sniffing dog. They use sniffing dog, so it takes time to train up that dog with particular smell and all. But nowadays, and they are using X-rays, gamma rays, radiography, etc., etc., which are very hazardous to health for those in these inspectors who are working on these cases. So now the research is going on. You see, will be within 10 seconds by using PLOT cryo. Porous layer open tubular, this cryoadsorption process, this method is applied, and this development is going on so that with the help of the vapor in this cargo area, they can identify within 10 seconds. Within 10 seconds. So this is that forensic area. This research is going on where our chemists are involved. These are the chemists, they are working on that. Then you see here, it is another one, explosive evidence found in fingerprints. Suppose you know fingerprints also, normally you have seen many, your Agatha Christie and James Bonds, all these, this cinema, they are fingerprints, they are collecting so that they are identifying the criminal. Okay, so here also, sometimes they cannot identify, but now that mass spectroscopy that is used, that is, and within a very, very short time, they are identifying the fingerprint and they are identifying the criminal. So these are also the research area and very, very important. I'm just giving these two, but nowadays all over the world, this kind of research is going on. Then here the cosmetic evidence. This is very, very interesting. In Asia, actually, the research is going on. Our Asian country, the girls, normally ladies, we use some eyeliner, then mascara, lipstick. So whenever lipstick, and the glass, when you are sipping some tea or drinks, the lipstick is there. Sometimes some kajal, eyeliners. These cosmetics are also different types. Like in different company, here also our different cosmetic companies are there. So they are, when giving their product as kajal, maybe they are different. So now forensic scientists, they are identifying that this kajal from company A, this kajal from company B. So when I'm using company A kajal, maybe the other lady is using company B's kajal. So this within very fraction of a minute, these have been identified by using ATR FTIR technique. So these are all developed and these research are going on. Then geochemist, from the name you can understand that geochemist, what is there? They do? They study physical and chemical properties of the earth, particularly rocks and minerals. So, and they can identify some area, some hazardous wastes are there or not. Now, next is there, this when hazardous waste chemist, it is also coming how? That is, they are also identifying any harmful chemical components are present in air, water, or soil. So they identify that, and accordingly we have to give the solution. This is a very, very important research is going on in Malaysia. So Malaysia, they are the palm oil. The palm oil industry, what is there? They are using this plastic pollution. They are non-biodegradable, the single-use plastics. They are plastics bags, food wrappers. Okay, so these plastics are making, very, very pollution in everywhere. So what they are doing, these Hemi Cellulose, that is, it is once again that you will see, sir told Professor Pal, the biology, you cannot segregate. If you know chemistry, you have to know biology. This Hemi Cellulose, that is also part of biology, if you say, but when the structure you will identify, that is chemistry. So this Hemi Cellulose, that is naturally occurring biopolymer. So what they are doing, this from your palm oil fruit bunches, from there they are extracting the oil and they are leaving, that is biodegradable. So they are taking all these and forming biodegradable films for green packaging. This is the utilization of that waste. And these are hazardous waste chemists are involved in these improvements. So what is that? This is that they are trying to protect our environment as well. So this is going on in Malaysia. These are research is going on in Malaysia. Now this is very interesting, that material scientists. So who are these material scientists? They study man-made and natural substances to determine their properties, then composition, and how they could be transformed. All these are the material science. I'll come that you will understand. So extremely good work has been done by the material scientists during this time of pandemic. Then pharmacologists, you can understand from that who are there, the development of testing of drugs, analyzing, etc., etc. These are the function of the pharmacologist, but they are from the branch of chemistry. They can come from that, the biology also. So this is your have been compilation. It is interdisciplinary. Toxicologist is more or less that pharmacologist, but they work on that, the deter harmful effect of the substances, etc., etc. These are the toxicologists. This is also one area of research. Now you come here, I'm going the first of all, this is very important research is going on detection of harmful chemicals in plastic toys. That is a method for quickly identifying prohibited additives in plastics. These plastic toys are coming mostly from China and all. So these researches are going on to identify immediately by touching the screen of that toys that any harmful additives are there or not. So if it is there, within 3 minutes, it can be identified the harmful plastics or not, within 3 minutes. So that any time, so it will help us to reject the material. We have to prevent to send it to the children, which is very harmful. So these are the research now it is going on. Then water chemist, these are water chemists, what they are also working with that water, and these are hydrologists and hydrogeologists. These two are the part of who are working on this water as water chemist. Who are the hydrology? Hydrology is actually basically the surface water. They are working with the river, lakes, etc., etc. And hydrogeology, it is that branch of geology. So, student, you can understand that here it is not the chemistry. It is once again the geology. So, geology also is connected to chemistry. So, in that way, it is totally, when science, it is interdisciplinary. It is interdisciplinary. So you cannot tell that only with chemistry I have the future, only with physics I have the future, only with biology I have the future. So these are very, very important part. Now I'm showing you why it is that the water chemist, what they are working now all over the world, the work is going on. This one. So water molecules that interact with near infrared light can show how pure water is. Previously, the work was there. Their water present in this, their physical, microbiological, chemical parameters, all there. But now they are thinking that how they are interacting with the water molecules. So as fast as if they see the interaction with the H2O, with that help of this infrared light, then their purity to be decided. That is the research is going on. One, just I'm giving example, many examples. Research works are there, but I'm giving a very, very simple example so that you can understand. Okay. This is another one, very important research is going on. The automated ICP-MS mass spectroscopy method that to measure bromine, chlorine, and iodine species and total metals content in drinking water. This is very, very important nowadays. Now, cosmetic chemist, mostly the girls, you know that in the TV advertisements are coming, lots of changes. This face wash is containing strawberry, this face wash is containing charcoal, and so. So definitely day after day, they are giving some input, which is good for health, like that. This is a skin care, that is the health care. And these cosmetic chemists are also nowadays very, very important, and they are working to look after the girls mostly. Sorry. And the boys are also involved. Here you see why I'm giving. This is Ashima Chatterjee. This is a very renowned chemist of India and Rajabajar Science College, and she worked under Acharya Prafullo Chandra Ray. So research means that Professor Chatterjee worked and find out anti-malarial drug. I think students, you know, the name is Ayush 56 from very indigenous plant. In Bengali, we call it as Shushni Shak. From Shushni Shak, that Ashima Chatterjee worked and find out this drug. Now I'm coming, the role of the medicinal chemist in drug discovery. As I required Ashima Chatterjee, that is, she was basically like organic chemistry specialist. And now medicinal chemist, you know that I don't have to say in this way what they are doing. I'm coming into that. Jayasri Madam is there. I think Jayasri Madam will explain properly. Here, the drug discovery, this is a process. It is a very, very lengthy process. A medicine, when available today, has required 12 to 24 years for a single new medicine this is a lengthy process. So here some stages are there to start with drug discovery. Means if you have to come one drug into market, you have to preclinical studies. Then first you have to form the research team. Then chemical synthesis, what chemical you will be using. Then test efficiency, etc., etc. After that clinical studies, then only it will come into the approval and then into the market. So it is a lengthy process. These are how these are drug discovery is a step by step. It is coming. Now, then I'm coming with that COVID-19 issue. This is the very most, why I'm taking this as example, because you will understand. So all of you are familiar with COVID-19, coronavirus disease 2019, and it is caused by severe acute respiratory syndrome coronavirus 2, SARS-CoV-2. Okay, say that I'm not coming. Now this SARS-CoV-2 structure, why this is a chemistry portion I'm coming. Chemistry, especially biochemistry, has responded quickly to this global pandemic by establishing the structure of this virus. So here is the function of the biochemistry, and they establish the structure of virus. How that all of you know this virus is having this structure. I'm not discussing about that. Just only I have to say they have inside this a protein, then the lipid layer, okay, and the protein spike. So you keep it in your mind. I'm talking about the lipid layer, bilayer, surface proteins and RNA genome. Inside that you see the RNA genome, and very, very important for chemistry part, that is the lipid bilayer. Face mask. Dear student, all of us, we know that face mask is now important. Now, during the pandemic, this a group of material chemists, they developed very, very nice that face mask that is self-cleaning properties with. What they use? They use that graphene. They use the graphene inside that this face mask. They use that. So why they have used this graphene? This graphene is nothing but allotrope of carbon, and this is hydrophobic in nature. At the same time, whenever this will be coated, the mask will be coated with graphene, then this due to this hydrophobic nature, the incoming aqueous droplet will be repelled or stick. They will not enter. Then the surface temperature on this mask rapidly increased to approximately 80 degrees Celsius. And all of you know, when this 80 degrees Celsius will reach that exposure to sunlight, then that our SARS-CoV-2 virus will be inactive. Okay, that is the important discovery, means material chemist they have done. So this is the graphene structure. Many of you know that it is allotrope of carbon, but a very good property. It is 40 times stronger than diamond. This graphene is used as a bulletproof also. Very important that I'm not discussing about that graphene. Graphene is having, then graphene oxide is also there. These are also used in various purposes. I'm showing that little bit research work. So these are the masks you have. If you observe, you will see that all masks here it is written graphene inside. Graphene inside. These are all N95 and graphene inside. You can now purchase this kind of face mask, so it will be much, much more safer. So this is that development in research, material chemist. Now come to that, here always doctors are saying that minimum 20 seconds your hand wash with soap. It is nothing but, dear student, this soap is cleansing action of soap on lipid, that is the oil droplet. how the oil droplet and the soap, they are functioning. So exactly the same is the mechanism over here. And now the step by step, the soap is having hydrophobic and hydrophilic part, and they are only completing the total destruction of the oil droplet. It takes minimum 20 seconds, the total process, the stages. And that's why here is the chemistry where doctors are advising minimum 20-second hand wash. So then only total lipid bilayer will be destroyed. These are that, I'm not going with that. Then hand sanitizer, that is also you are using, where we are using the chemistry, and this is also that how after discovery of the structure, when it has been seen that it has a lipid bilayer, if we can destroy the lipid bilayer anyway, then definitely the virus will not be active. So what are the hand sanitizer? Especially we use alcohol. All of you know IPA, isopropyl alcohol. Normally we can use ethyl alcohol, then water, glycerol, and hydrogen peroxide. But hydrogen peroxide is not used in hand sanitizer. Hydrogen peroxide is used in the surface sanitizer. Surface. So 70% isopropyl alcohol has been advised. Why? Whenever it is 70% isopropyl alcohol, then approximately 30% water is there. So when you are using that alcohol, 70% isopropyl alcohol, it takes little bit time to evaporate. And in the meantime, that will be destroyed. The protein will be denatured and the virus membrane will melt. So virus will be deactivated. These are that. Then drug development, as you know, during COVID time, sometimes antibiotic and so many drugs are first wave, hydroxychloroquine. But actually, I told you the drug is not so easy to prepare within 6 months or 3 months. Because of this, during COVID-19 situation, that repurposed drugs are being used. That is investigated. What is that? The existing drugs have been repositioning, just maybe from they are adding one and other, then they are applying into the patient's body. Okay, so this is a universal, this repositioning of the drug is the universal strategy. These are the different steps, many are there. So now the 4 most promising repurposed drugs that was approved internationally, that all of you know, hydroxychloroquine, remdesivir, lopinavir, all these are there. These are the repositioning of the drugs, but not the exactly drug has been discovered. So here is that modification of the hydroxychloroquine that has been also done. Next, ongoing research in chemistry. I'm finishing very fast because time. So now I'm coming with the graphene. Graphene is working. It is called as the wonder material in 21st century. This detecting bacterial contamination with graphene. Graphene is used. This work is going on. Disposable sensor built with graphene could make it cheaper and more convenience to check for bacterial contamination. That is also graphene is used to identify the bacteria. Okay, so this is the research on graphene. Here the energy chemistry, another one portion where these are also research is going on, different area. Now the recent progress in the electrochemical ammonia synthesis. All of we know Haber-Bosch process, we are synthesizing ammonia industrially. But now this is not using. Now the research is going in a different way so that we can find out this one in the agricultural chemistry. This load, I'm completing finally this one with nanochemistry, and excellent research is going on in our India. As sir told, no, biology, chemistry, everything is interrelated. You will be surprised what research is going on. They are making solar cell by using chlorophyll from plants. With the help of this chlorophyll they are taking, normally this is PSG Institute of Advanced Studies, Coimbatore. This team, they are research is going on with that neem leaf they are using now. Now they are using neem leaf and they are extracting, they are taking chlorophyll and they are preparing solar cell. And I'm showing you, this is the stainless steel mesh. They are using zinc oxide nanofiber. And here is that the chlorophyll from that neem leaf. So these are interrelated, biology and chemistry. So these are the research work and it is going on in Coimbatore, this in India. Now they are also suggesting the Coimbatore, the team of research, one of my friend is also there. And he is Kannaviran is saying that this is now they are trying to find out chlorophyll from water hyacinth. Water hyacinth, if it will be viable, then it will help our environmental benefit also. So then synthetic chemicals in obesity, that is also the research work. And I'm just finishing. So all the best students, if you have lots of questions and afterwards I'll be going that. Apart from that, if you want that to contact me, you can send your question. So thank you from my side. Thank you, Vijay.
Thank you so much. Thank you so much, ma'am, for that enriching, relevant, impeccable session. We now move on to a very, very eminent speaker, Professor Jayasri Das Sarma, who needs no introduction from any of us. Her latest research has been on coronavirus only. So I'm sure you're going to enjoy this session. And to talk about a little profile of ma'am, ma'am has completed her PhD in collaboration with the Indian Statistical Institute and Indian Institute of Chemical Biology, and her postdoctoral work at the University of Pennsylvania, Philadelphia, USA. And then successively, she joined Thomas Jefferson University Neurology Department as an assistant professor. She is currently a full-time professor at the Department of Biological Sciences, IISER, Kolkata, and she is also an adjunct associate professor, Department of Ophthalmology, University of Pennsylvania, Philadelphia, USA. She is an elected fellow of the West Bengal Academy of Science and Technology and has been recently elected as a fellow of the National Academy of Sciences, Indian Academy of Neurosciences, and the Indian Academy of Sciences as well. Her group is involved in the study of coronavirus-induced disease biology by using murine beta coronavirus. In short, it is known as mCoV. Infection in mice as an experimental model system to understand the viral genomic determinants of pathogenic properties to identify therapeutic targets. And we have forwarded the questions from Explore International Singur, DAV Public School Raniganj, the BSS School Kolkata, DAV Model School Durgapur, BDM International Kolkata, DAV Taratala, and Aditya Academy Kolkata, and also a question from Asian International School has been forwarded to ma'am. Over to you, ma'am. We have made you wait for a very long time, but I am sure I seek apology for the delay, but I am sure children would be enriched to the core by hearing you out. Over to you, ma'am.
Thank you, Principal Ma'am. Thank you very much for giving me an opportunity to give a motivational talk to the young students. I remember my days when I was a young student. It was one of the challenging questions, like what to opt for as a career. And I always think this is one of the things the young generations and the teachers need to guide, and the students need to see where their interests are. Because I believe when the interest and the hobby can be a career, that is the best we can have it in our academic career as well as for our earning, for our bread and butter. So that's what I will start my talk. And my sincere thanks goes to the entire Asian International School for arranging this webinar. And my thanks also to my previous speaker, our director, Professor Sourav Pal, and principal madam, and also Apala Didi. She was my senior, and she gave us just a few minutes back. She talked about the chemistry as why it is so important to know and to understand. And my job is to talk about biology, how to choose a career in biology, and why we need to know biology. So just to start with that, biology, as Professor Pal was mentioning several times, then Mrs. Apala also mentioned that biology and chemistry, physics, there is no boundary. We cannot say that biology only we can study. But I must say that biology is a very dynamic and multidisciplinary subject. And most often we use that term biological sciences or life sciences because it has an enormous field, and it is the impact of biology in each and every day-to-day life, as well as in each and every moment of our life. So we need to know ourselves through biology. So that's what I'm going to cover today, and how to choose career in biology, and what subject to choose, and what are their other allied subjects to make it as a career. So as Professor Pal started talking about that, anything, if in a glass of water, you can see that there are atoms, but how to see, that's what you need to know chemistry. Same way, biology also starts with atoms. A non-living object from a living object. If I ask any biologist, the first question is, how a living object is separated from a non-living object? What are the entities of a living object? So two questions comes, that they can produce they can replicate among themselves, and they can also grow the population, as well as they can respond to the external stimuli. But how to do that? To know that, we need to know what are the units in our, or atoms or molecules the biology starts with. So we all know that DNA is the genetic material. It is a hereditary material. It goes from the parents to the next offsprings, and that's what we start. But to understand the DNA, we need to know the molecule. We need to know what are like DATP, DGTP, DCTP, and DTTP, that are nucleotides which makes the DNA. And then how they form the spiral structure, as I'm showing it here. That comes under the structural biology. But to know that, we need to see how the molecules and atoms are aggregated to give a DNA structure. And then DNA, where it goes in the cell. So it is in the nucleus, we know that. And that's what we need to know, the organelle of the cell, different organelles. I'm sure all of you know that cell is the building block or unit of the living object, and it has several organelles like nucleus, nucleolus, then Golgi apparatus, and then there is a powerhouse called mitochondria. There are cytoskeletal proteins, cell cytoplasm, endoplasmic reticulum. Together, they give a definition of a cell, and these organelles, when they are in inside the plasma membrane or the plasma layers, then we call this is a cell, and this cell is the living entity. It is the unique, and that's what these cells, they have all the property, but similar type of cells or different type of cells, they form the different tissues like connective tissue, epithelial tissue, nervous tissue, muscle tissue. And we know when all the tissues are working in different places, it is called organs. Central nervous system is an organ, lung is an organ, and they work together to total body, or the function of the human body depends on the coordination of all the organs together, like circulatory system, respiratory system, excretory system, digestive system, nervous system, together give a living entity, and that is the complex human body you can see. But even we will see from a single cell animal how they respond to the stimuli. And here I will give emphasis on the nervous system, because I think that is one of the important systems which is a complicated one. So I will discuss a little bit about the nervous system to explain. But before that, I would like to say that when a living entity is taking a space in the biosphere, it is called population. So you can see throughout the globe, we have a large population of human, not only human, all types of different living creatures. And that comes under the ecosystem, because without the ecosystem, we cannot function, because we don't know how to synthesize our energy. But the plants, they have the system to trap the solar energy and to convert to energy, which we are taking at different forms. Either directly, vegetarians are taking directly the vegetables, green vegetables, and also the other vegetables, whereas that, who are non-vegetarian, they also take meat, fish, which are in the food pyramid and the food web, and they together make an ecosystem. And this ecosystem, where living objects are there are also atmosphere where we take our oxygen, our nitrogen, carbon dioxide, as well as the water, hydrosphere, and lithosphere is the rock, and they together form with the ecosphere where we have the lives. Together we make the biosphere. So think about it, from a single atom to a complex biosphere to come, this entire thing is covered in biology. So now, if I say, as Apala Didi said very nicely, that there are chemistry is the first subject. There are lots of branches. It is true for biology. And it is not only one subject, like, when you are teaching, we are teaching in undergrad, then we say the biological sciences or life sciences. But then when we go in the graduate course or research, then biology has lots of branches. And tell you the truth, if you ask me to name all of them, it will be really difficult. But still, I try to write down some of that so the students can have a glimpse of it, like, botany, zoology, physiology, bacteriology, then, marine biology, genetics, embryology. All this comes under branches of biology. And you can see here from genetics, evolution, then molecular biology, veterinary science, science of medicine, fishery, forestry, everything comes under the branches of biology. But if I design a course, when you will come for your undergrad course or graduate course, you will take biochemistry, biophysics, immunology, cell biology, embryology, developmental biology, and genetics and neurobiology as a core course. But then you will go for the more specialized, which is molecular biology, structure biology, gene regulation, biotechnology, radiobiology, pharmaceuticals, and photobiology. So that is like, these are the tools and techniques which are helping to understand all these core subjects. So that's what we think, like, first definition of some branches is very important, like biochemistry, where chemistry and biology are interacting together. Like any system, if I talk about, you cannot go without chemistry. It goes hands in hand. Like DNA, as I said, there are nucleotides. In the protein, there are amino acids. So when we will go, that individual amino acids forms a peptide, and that forms a protein. Similarly, you can see the different nucleotides are arranged in a fashion which can give us spiral structure of DNA. So these things, when we study in biochemistry, biophysics is very important to understand what are the basic laws that are working behind that. What are the forces? What are the mechanical, pressure, mechanical torsion are working there? Then if I come to plant physiology, then you will see that how the plants are, there is a xylem, phloem, how they are taking up the water to the leaf for synthesizing their energy. And then by taking the advancement of that, we can talk about photobiology, which will talk about the ultraviolet light and visible light, and it helps in irradiation of the living organism. And also this photobiology now not only confined to this understanding the ultraviolet light or the visible light, it includes topics such as photosynthesis, vision, bioluminescence, circadian rhythm, and photodynamic therapy. So simple plant biology, plant physiology knowledge will help you to think about and to study this very important thing. Like when people go to space, we need to think about the circadian rhythm, and that we can't get to know from photobiology because we have a daylight cycle. When we do mouse experiment, we have to maintain daylight cycle. So that's what photobiology is originating from. The plant physiology or animal physiology is giving us the avenue to study further. Same way, immunology with the COVID, as Apala Didi just said, that COVID they made us understand how chemistry, biology are working together, because viruses is a living entity when it enters into the cell, but our body regulates, body has a system to check, and that's what is the immune system, which can attack other pathogens. They have the system, body gets inflamed, and this inflammation removes the pathogen and body comes back to the homeostasis. And while we are doing that, there are more specialized technology-oriented subjects like molecular biology, where we can make the knockout mice, knock-in mice, and we can study the particular proteins, cytokines, chemokines, that how they function. When we are doing that, biotechnology is a buzzword today, because any engineering we do at gene level, at protein level, at molecule level, it comes under the biotechnology. And there are lots of innovation and innovative grants are given by the government to engage students in biotechnology, so that they can be future generation scientists who can make the medicine better. They can increase the health. And biofuels, we also use the biotechnology, and that sustainable energy, what Professor Pal just said, we need the help of biotechnology, because we need the engineering. We need to do the engineering, but we have to engineer our mind. And this engineering of the mind comes under neurobiology, where we also study marine biology, because, when we are thinking, we can see the plants and us in the earth crust, but there are so many living creatures in the deep water sea or shallow sea, and they also contribute to the ecosphere. So that's what it is very interesting to study marine biology. And nowadays, radiobiology is very important, because any chromosomal aberration or genetic defects, birth defects can be corrected by radiobiology. So these are some of the definition of the biology branches, but that is not confined to only these branches, because it is a complex system. So I thought I can take an example of a nervous system and can explain to you that how complex is our system is, and how we can take the complex system, we can divide it into branches to understand in a holistic way. Like as I was talking, that any living creature can be separated from a non-living object like a stone, because they can respond to the external stimuli. So I know I have eyes, I can see whether there is a butterfly or there is a tiger, but see a small animal, the amoeba and paramecium, which is a single cell. They can also respond to the external stimuli because they have photodetectors. Single cell is performing all the function. So we have to understand that simple thing also can respond to the external stimuli, so that we can use for our devices. Same for euglena. They have the flagella. One single flagella can sense the light, temperature, and the gravity of the situation, and also the density of the solvent, so that they can move. Whereas sponges are multicellular organisms, but they do not have any nervous system. Throughout the body, they respond to the external stimuli. But see, the complexity arises. You can see the hydra and human. You can see here it is a nerve nape throughout the body. There is no central part. But the human also, you can see that so there are so much nerves. It's called peripheral nerve. And the red one is denoted the central nervous system, brain, and the spinal cord. But in between that, how the evolution goes, you can see C-star, planaria, leech. The concept of nerve being a centralized concept is coming. Then ganglion, accumulation of the cell body is coming. In that way, it came from the insects to mollusk to squid and to chordate, where brain and spinal cord concept came. And now we can see in our complex nervous system how they are coordinating. So that's what if we need to understand the neurobiology, we need to take the help from each and every branch of science. Like cell and molecular biology, like when we study, all of you know what is neuron. If I ask that question to the students, everybody will be able to answer neuron. But how neuron interact with other glial cells to give the function of the brain is a challenge today, is a question today. How many neurons we have? How to know that? And then we know the neuron is covered by a myelin sheath, and myelin sheath helps the nerve impulse to go faster. And what happens? There are ion channels, and that causes a membrane potential. And these electrical circuits, to understand, we need the help from the electronics to understand how billions of neurons are interacting to each other to give the function. Today I'm speaking how my vocabulary is coming, which part of the brain is involved. It needs thorough understanding of the electrical circuits. And then how the brain develops. Why our brain is so much complicated, where our two hands are free. We can do the work through hand, we can write, we can see, but single cell cannot do that, but they can also respond. But why we need that this much complicated process, and how developmentally it is done? Why a neuron has so many dendrites but only one axon? That depends on the diffusion reactions, and that happens through stochastic process like magnetism in physics. So we need to understand the stochastic process. Means for a certain time there are differences in some of the factors which are growth factors, and they decide one will be axon and there will be so many regions will be dendrite. And to understand all these, we need the help from the neuroimaging tools. And to understand the neuroimage, we need to know the physical principles behind the tools and techniques which comes under physics. And when we do that, why we are doing all this? Because we need to know our brain. We need to know our behavior, because the mental process is hardwired through the neuronal architecture. As I said, the electronic function of the neuron, how the neurons are working together, the synaptic integration, neuronal network requires the help from computational biology. And these network theories helped us to understand the mental process, which is a cognitive neuroscience. Why? Because we need to know how we can learn things, how we can memorize, how our mood swings. Today I'm in a very good mood. I talk to you very nicely, but sometimes I'm not. Why? Because my mood is not right. But why my mood is changing? Why sometimes I feel depressed, or why there is a depression? It entirely depends on neurochemistry in the synaptic region, where there are neurosecretory materials, neurohormones. The alteration of their level causes people to be depressed. And in family, if somebody is depressed, we try to yell at them, we try to tell them that they are lazy, but we do not understand that they have some neurological problem. And if we know that, we can treat that, and the person can be functional, person can contribute to the society. So that's what we need to know our brain very well. And then there are cellular and molecular bases, which we can take the help of, like molecular biology, as well as the cell biology, and all the help from these tools and techniques. So now if I come, why different branches of biology I'll study? I think I have explained to you how the interdisciplinary subject works, but biology is a study about life. It starts from the very beginning. Like if you say, who nurtures us? Our parents, our mother. Mother need to know how the system works. So if we think it is only for our career, no, it is for our day-to-day life. It is to nurture the next generation scientists. It is to also nurture our society, and also to take care of ourselves. We need to know how to take care of ourselves. We need to know how to keep our brain functional, so we are not going for aging, because nowadays aging is a big problem. For that, we need to know our brain very well. So that's what I think in various life forms provides deep scientific knowledge of how all living and non-living beings interact with each other in the environment. Today is a day we realize that we altered the environment. We didn't maintain the food pyramid. That's what today from bad, the SARS-CoV-2 came to human. So there are some specialized branch in the field of biology which will help to understand and that sustainability of life, food quality, causes of illness, environment and ecosystem, development of medicine. So if we need to understand that, we have to know our bodies, our physical appearances, various metabolic reactions within the body. Like most of us, like even I could not say most of us, I'm very careful about how I look like, how my hairstyle is, how my appearances are. but I never think about how my metabolic system is working, how my digestive system is respected, how my nervous system is respected. I'm working like, I have high ambition. I'm working hours after hours, but I'm not understanding how to give rest to my brain so that brain can function better. So to know that, we need to know each and every aspect of our organ system. That's what it is very important to understand the biology. And from botany and anatomy to biotechnology and genetics, it can give us diversity in career because we need to earn. And also not only to earn, I may not need to earn. I may have enough money, I can stay at home, but I have a social responsibility to teach or to whatever knowledge I gather to give it to the next generation. So it is called knowledge transfer. That's what I have to have thorough understanding, and then only I can convey the knowledge what I'm gathering. And then large scale problems like existence of population, increasing population growth, of infections and disease, food supply and food storage can be studied, and solution can be discovered using the application of various branches of biology. Because we need to do that. If we think we have a refrigerator, we keep the food for 7 days, we are taking the food where bacteria grows. We think, no, bacteria is not there, it is 4 degrees. No, there are some, cold situations of viruses can grow. That is called thermophilic bacteria, thermotropic bacteria, they can grow. And these things together can give a career, create a path of scientific investigation, thus enhancing our chances of establishing a flourishing career in research. I think research career, if you ask me, this is the most safest career in the world, where you are not that much answerable to others, but you are answerable to yourself. That what innovation, as Professor Pal was telling, what innovation, what new things we are inventing, because Louis Pasteur did some, then Leeuwenhoek did some, but what I'm doing, I have to ask, not only me, all of you have to ask that, okay, government gave us fellowship, schools are giving money to support my studies, but what I'm contributing to the society, that's what we have to make. This is the very noble profession. I can tell you, in research, if you respect each and every penny you are spending for research, because this is all taxpayers' money. And that is very important today to convey the message that we are sitting under AC and doing research, but we need to be careful about it. And I think encourage the concept of basic living, how we can make our living better. It is not only to earn money, not only to do up good clothing and just go and talk to people, go to coffee board, drink coffee, drink tea. No, it is to coach as individual to plant trees in order to create a healthy environment. So we can respecting our ecosystem, and with knowledge about the temperature of the human body also, we can build shelters effectively, because we think we can go anywhere, we can study anywhere, but we need to know how to adapt. So adaptation is very important thing. I think my time is coming almost over, so I'm not going through to talk more about it, but I can share the slides. You can see that biology, understanding biology in coordination with chemistry, physics, animal sciences, botany, then the alternative medicine, Ayurvedic medicine can help to come to a limelight to avoid the side effects of allopathic medicine in complicated disease like diabetes, kidney failure, heart, lung disease, as well as nervous systems. And the diverse scope of biology will give you a scope of your career, bioinformatics career scope, as well as job prospects in so many branches. You can see from medical doctor to biochemist, biophysicist, veterinarian biology, bioinformatics, wildlife biology, to name a lot of them, forensic science, environmental specialist, microbiologist, biomedical engineering, biological science teacher. And not only that, medical writer or scientific communication course gives us how to become a very good in scientific writing. I may think my science very well, but my language is not good. I am not a good writer. So somebody can help me who can understand my subject and can also help me in writing. That also is called scientific communication course, is coming up more and more in limelight. And medical laboratory technologies, because nowadays we do remote controlling, like neurorehabilitation as well as monitoring of the disease. Like for COVID, there are lots of online directions are going to people. So we need to know that how we can improve our technologies. And tell you the truth, today the e-courses helped. So for that, you need to study in different branches like BSc, MSc, in genetics, biomedical engineering, M-Pharma, biochemistry, bioinformatics, veterinary science, healthcare, nanobiotechnology, agricultural science, and then industrial biotechnology for sustainable energy, as well as biofuels, biomedical engineering to help the doctors, and marine biology, all this together, and microbiology, of course, today we need to know in detail. And these you can study in different places. In India, we have ISOs, we have IITs, IIScs, several universities, as well as in popular universities for biology. Internationally, you can choose any of the universities and you can get very good training there where you can build up your career. And I should end with that artificial intelligence, because the computational science and bioinformatics is very good in India, and artificial intelligence gave us a perspective to accumulate the big data in disease biology. So the public repository or experimental data can help us to do the integration through integration modeling and annotations. And so we can have raw data, then we can have clinical data. Like just from the outside, doctors can suggest that facial paralysis or the brain tumor, what is going on. But we need to do at RNA level, protein level, and metabolite level. And then we can have all this data, high throughput data, through algorithm. We can make it a grouping and clustering of patients, and then we can use them to test the drug X and drug Y. Drug X may work for some people, where Y may work for some people, but drug X may cause toxicity to some people, and drug Y may not cause any toxicity. So that's what we need, the personalized medication today, and that is only possible through these AI technology. So artificial intelligence, machine learning, deep learning, they all are like one to another. All the data, like artificial network, we can get the deep learning, and then from there we can use that machine learning, and then we can use that as artificial intelligence to do the data mining. And nowadays we are using that in engineering, communication, healthcare, robotics, and manufacturing. And that helps to understand also the billions of neurons, how they are working. IBM is doing a blueprint project where they are trying to understand the function of individual neuron, which we cannot attend by any neuroimaging tools or techniques, or by studying neuron in culture. So that's what I think all branches of science have contributed to our understanding the biology better, biology, chemistry, physics, mathematics, and computational biology. And I must end with their contribution to COVID-19, because it is a virus. So we need to know the virology and cell biology, how it is interacting to the host cell, the lung cells, and also in different parts of the body, how pharmacology came to help to design the drugs, and small molecule chemistry, then social workers, how they are helping to combat the disease, paramedics, healthcare works, and e-networking. Today we can give a talk, because though we cannot travel, but we can talk through the e-networking. So this e-networking is a contribution of COVID-19. Though COVID-19 made lots of disaster, it also taught us how to adapt in a altered environment. It is called new normals. And of course, the immunology and vaccine designing is helping to to give us the vaccines, and now we are ready for booster dose. So I think to understand ourselves better, understanding of biology in combination with other fields of science is very important, and that will give us a good career. So I thank you all for your patience, and thanks the AIAs for giving me an opportunity to present and to share my insights with all of you. Thank you all.
Thank you so much, ma'am. It was indeed enriching. Ma'am, the first question as a fan of yours would be from my end. I'll take that liberty of asking you a question, that if a student wants to join ISER, what are the methods, what are the examinations they need to crack, what is the preparation they require. If you can please give us a little light, because I think this is a common question in the minds of most of the participants, right? I can see Shashank Singh from Martinia boy is nodding his head, and I can see Jisha from Asian International School also coming up with a smile that probably I've spoken their mind out to you, ma'am. So please enlighten us on that. Ma'am, please unmute yourself, ma'am.
I think I should request my professor, our director, to say, because he's directing the ISA Kolkata. So, Professor Pal, are you here?
Yes, ma'am, he's there. Sir,
maybe he's busy because he has several meetings. So let me tell you, like, we have a joint admission committee. So there are advertisement after 12th standard. Students can go through joint admission process, and they can also come from the regional schools. They can compete and they can come to this. So there are advertisement in the ISA Kolkata website. So it is detailed. You can find the detailed information. Due to time constraint, I am not going to talk much about it. But joint admission committees, entire SOP, like standard operating procedures, how to appear for the exam and how to come for the counseling, how to choose which ISAs you are going to go. All these things are written very well. So if you can contact Shushmita Bhattacharya and our Dean of Academics office, they will be able to help you. But it is a very open system. So we made it so open that, the people who are really interested to come for science and research, they only will come through that. The questions are prepared like that. And there are lots of exercise going on to prepare the questions, but nobody knows what will be the question. So that's what, again, we take the help from the computer science. So there are sets of questions as prepared by different faculties from different ISAs. But then they are so jumbled up that nobody knows what will be the question. So there are no nepotism or anything. It is a very open system.
Thank you so much, ma'am. Over to you, Orithro and Costa.
Yes, ma'am. Thank you very much. So now we will go with the few set of questions that we have handpicked and have come from the students all over the country. Firstly, I would like to ask a question to Apala Chakraborty, ma'am, which has come from Bakshi Jagabandhu English Medium School from Khordha, Bhubaneswar. So, ma'am, my question through his medium will be, as we humans, as an organism, have evolved from one entity to other, so will it also mean that in the coming times, our body will also have new living structure? This is the question of the student.
I think Jayasri Madam will answer this clearly. It is Jayasri Madam's part, ma'am.
Yeah. So Aditya, can you repeat the question?
Absolutely, ma'am.
It is Jayasri Madam can answer it better.
The question from the student is, as we humans, as an organism, have evolved from one entity to other.
Yes.
Will that also mean that in coming times, our body will also have new living structures?
Okay. So to tell you the answer, we know we have several organs like appendix. It was there. So you might have studied in evolution that there are use and non-use. Like if you are not using some system, it will be slowly non-functional. And if you use something, it will be functional. I can give you organ. I'm not sure whether there is any space to accommodate any organ. But I can tell you adaptation will happen in such a way the organ will be modified. Like say, when I born in Calcutta, I may learn how to speak in Bengali. But if I was transferred when I was young to Tamil Nadu, I will learn Tamil very quickly. But if at the age of 20, if I go to Tamil Nadu, I may take time because my neuron already made the word. Whatever language I'm listening, that I am trying to speak. So that's what, it is called adaptation or neuronal plasticity. So I say that there won't be any new organ, but the function will be different. Like say, if I want to go to a very cold place, like the food habit needs to be a little bit changed, because that which will keep my body temperature retained when the outside temperature is very low. So that our hypothalamus, which is regulating the temperature, will be accommodated to the temperature change, rather than a new organ will come to control the temperature. Same way, when we have an increased blood pressure, then the brain should burst, right? Because brain has a very well architectured blood supply. But it doesn't happen because we have auto-regulation. When pressure is very high, blood vessels dilate. So that way we have our system, and that is adapted to the new environment with some modalities. That's what we call emergent properties. The new properties will come, but organ as such, like if you think another kidney will come, like if I eat lots of junk food and to excrete it out, do I need another kidney? No, rather I have to control my food habits so that it is not bothering my kidney. That much I can tell you. Did I answer your question?
Thank you. Thank you so much, Jayasri ma'am. It is such an honor listening from you, Apala ma'am and Sourav sir. I got the answer to my question. Thank you so much.
You are most welcome.
Ma'am, we would now invite Vidhu Bhushan Patra, a student of class 11, DAV Public School, Unit 8, Bhubaneswar, to place his question. He has written a question in the chat box, but we would like to hear it from him, because we celebrate asking questions.
Good evening, ma'am. Myself, Vidhushan Patra from class 11 of DAV Public School Unit 8. And my question is that what are the requirements or what are the things left by the present researchers to build a permanent or step base for the future generation to research safely?
Shall I answer this?
Sure, ma'am. Thank you so much.
This is no scope as that the safer and all. Research is such an area that you have to be into that. You don't have to wait for that. The who are left behind or who are doing what. It is your brain will work, what you want to do. That is the research. It is not that anyone is doing. Like chemistry, when we are teaching you, we know that. Okay, this is the structure of benzene, it is fixed. But now when you are going into research, that this benzene is with you, now you add some groups into benzene, you add some, then a new compound will be coming. That is your research work. So no kind of question the safer and all. Everything is safe. You do it. So this is not any question, the safer and all, everything is safe. And what are there, you can improve that, you can modify that, you can revise that. Clear?
Thank you so much, ma'am. We now invite Sanglap Maiti to put forward his question. Sanglap, please unmute yourself.
Yes. Hello, everyone. Good afternoon. Good afternoon. So my question to those of you there
which
is that
school are you from? Which school
yes,
are you from?
I am from Sri Academy, Kolkata, and my question to you would be that how is it possible, or what are the prospects of pursuing an education in quantum biology, or and eventually pursue a career with it, go into research, delve into photosynthesis, and just probably some other factors also.
So, Apala Didi, you want me to take that question?
Yeah, you please take the question.
So, Sanglap, it's a very interesting question, and that's what I think you need the interdisciplinary approach. Like the quantum mechanics, if you see the quantum mechanics in physics, they give a course of quantum mechanics. And in biological system, the stochastic reaction, what I just mentioned to you, like say when the neuron develops, there is a ball, right? Like this ball, like neuroblastoma. Then there is a stochastic reaction for a single point, and for a very short time, even it is very like low scale, not even like seconds, or it is below maybe in nanoseconds. There are accumulation of certain factors which helps the accent to grow. So in that time, these dynamics to understand, we need to have this quantum mechanics and how this system works. So if you have the quantum mechanics as a physics course and you know the biology, like especially the developmental biology, where we require lots of this physics help from the physics to understand the developmental process, it will be a great help. And for that, students will be the best teacher because see, I know biology. Physics teacher knows physics. But if you ask me at this stage for me to learn biology, physics, quantum mechanics, I think I forgot quantum mechanics because I have hardly studied little bit. Now to study, as I said, my neuron already is busy in so much work in administration, teaching, research, my taking care of my students, publishing papers. So I may not be able to learn, but you are the person who can, you can learn mechanics from physics and you can learn biology from us, and then you can bridge us. So that's what we are hopeful, and that's the vision of ISER, all ISERs, that we can train, we can nurture the young mind in such a way that the questions, what is left, like somebody just before asked that question, that what question will be left, and we have to understand that this type of questions we need to know. Like see, learning disability. Okay, when a kid in a class, like say 20 students are there, one student is not concentrating on the studies, what I am teaching. What will be my first reaction? To yell at him, right? Why you are not listening my lecture? I am giving. But if I know that, maybe he has learning disability, he's not understanding what I'm teaching. So what I have to do, I have to give him a special attention. But if I don't know that neurobiology, that, it is a birth defect, we have to correct it. He may be very good in some other career, like where he can be a very good machine shop person, but he may not be good in memorizing things and writing in the answer script and get good marks to go to a good school, but he has a potential career too. So that's what I think it is very important now to understand each and every system. Like say digestive system, we have so different digestive system. Like sometimes people in a home, they think, why you don't eat in somebody's house? I may fall sick because my digestive system doesn't know how to digest that. Like say onion and garlic. Almost in Bengal, everybody has take onion and garlic. I can't because my digestive system doesn't know. But some people will think it is a vegetarian thing. It is a vegetable. Why you are not taking? But my digestive system needs to be trained for that. So that's what we need to know our system very well, where we need to also think about how we can understand the system better, like enzymatic reaction of the liver. If liver function is not good, then, assimilation won't happen. So that requires chemistry knowledge, enzymatic chemistry, right? So that way you can contribute in a significant way by interdisciplinary subject.
So, ma'am, for quantum
mechanics. Thank you so much. We'll move on to the next.
So I want Shonglap, very recently the research is going on, quantum chemistry of tree leaves. I think Jayasri ma'am know it. So quantum chemistry of tree leaves, you cannot segregate in that way. So if you study these leaves and all, how this quantum mechanics or quantum chemistry is involved in that part, it will excellent. So please go on with that.
Thank you so much. Think, how against gravity, the long tree can take the water. It is going against gravity. There also you need to know that, how it is forming the water layers there, how it is helping to go.
Thank you so much. Now, next question can be placed by Vaibhav Tripathi. He is from a school in Prayagraj. So, Vaibhav, please share the name of your school with us and please put your question forward. Thank you. Vaibhav Tripathi.
Thank you, ma'am, for calling me out. Good evening, respected dignitaries. My name is Vaibhav Tripathi of Sri Mahaprabhu Public School, Prayagraj, Uttar Pradesh. My question is that as we are moving in the development and growth of science and technology, but as a young researcher, what should be the message for all of us that analysis of problem which is a fundamental thing for any research work or innovation or invention. Because if we are able to analyze the problem, then we will be able to work upon it. So what would be the preferred message from all of your side to us, that how can we analyze the message and transform it into a great idea, innovation or invention? That's my question.
You may proceed, Jayasri, or myself also. You tell. I'll add later on.
Okay. Vaibhav, it's a very interesting question. So any problem, like, there was a Kishore Vaigyanik program, that, right?
Yes.
So there they used to give the small projects. Like, say, you want to make some like antibiotic, antifungal. You can think about what is going to happen. Like, what will be the property of antibiotics or antifungal. So you need something which can make a pore in the bacterial wall or the fungal membrane, right? So that it can burst. So that's what, from your knowledge, if you can study nowadays due to Google search and due to this internet search, you can find lots of literatures which will guide you. Then you think what new you can do. Like, say, bleach, right? If I pour a concentrated bleach, there will be a lots of problem, hazardous problem, like, it may come to my clothes, it can come to my feet, it can also burn my skin. But, if I make it 10% bleach, it won't be that effective, but it will affect the bacteria, it will affect the fungus. But it may or may not. So we may need to add to that so that it can work better. Okay, so we can use 5% bleach and we can add something which will increase the property of the bleach to cause the disinfection. Same way, say, in lots of our houses, we get the molds because the paints we use, that is not antifungal paints. It's very expensive. If I tell everybody to use the antifungal paints, it is not possible because I have to think about the cost too. But if I can add something to these paints and can make antifungal paints, that will help us to protect our house. Same way, you have to think whatever it makes you interested, you can take a small project and you can communicate, you can reach out some of the faculties in different IITs, ISOs, and you can ask that I have this in mind. Can you help me? What can I do? We get lots of mails, and summer they do the program with us. So we tell them what are the problems. Like when COVID came, I think I trained 35 people on different aspects of COVID. So in that way, if you reach to the faculties of different institutes, they will be able to help you. If you ask me a question which is a quantum mechanics, I may not be able to answer. I will send it to my physics colleague or computational science colleagues, and they can help you. If you send me a question about computational chemistry, I will send it to Professor Pal or Dr. Nilanjana Sengupta. So we know people. It is called networking. As I say today, that through the virtual platform, we can do networking. In that way, you can think about a problem which is bothering you or which you think you can contribute. And that will help you to find out a solution. And maybe in future, you will be able to help. Like arsenic is one of the problem, How to remove arsenic from water. There are so much research is going on. So many people are trying to make filters. Can you come something like that? Or lead? Okay, pesticides, you can think about, like we are getting lots of plants with pesticides. Can we make a pesticide which will kill the pest but not kill us? For that, you need to know the basic mechanism.
Thank you, ma'am. Over to you, Costa.
One minute, I'm telling just 1 minute. That Vaibhav, the research, when first you think, constructive thinking, and you see surrounding you, what is the major problem you are facing? And you just construct that how to remove, how to solve this problem. And you come into that point of research work. It will help.
Thank you, ma'am. Thank you so much.
Costa, over to you.
Thank you, ma'am. Good afternoon, all dignitaries and respected teachers present here. I would like to take this opportunity to present my question to Sourav sir.
The question is, this is from a question that I've received from PSS school, that with AI affecting every prospect of our daily life, how in the upcoming years, especially with the advent of
Yeah,
technology,
just tell me.
it can help in the chemical research field.
What did you ask? Chemical research field?
With AI affecting every aspect of our daily life.
Yeah. Chemistry, a lot of AI. For example, the catalysis design itself can have artificial intelligence. Pharma drug discovery. So wherever there is a large data, like in design of a catalyst, is very difficult. De novo design, which means you have to search for all types of metals, these ligands, where it will attack, different types. So it's a huge amount of data you require. Similarly, drug discovery, it's a huge amount of, or any de novo material design. So all those cases, normal computational chemistry or biology can only give you some results, but you can't span the entire set. So you need to somehow expand and extrapolate your calculations, and there AI and ML will play a very important role.
Thank you, sir, for the information.
Yeah. Wherever there's a data, big data science, it's all impacted by AI and ML.
Thank you, sir. We can now have Agnirup Chakraborty from Aditya Academy Secondary School, Barasat, placing his question. Agnirup, if you are there.
Am I audible?
Yes, you are.
I just wanted to thank all of you, because I have another meeting at 5. So, okay, thank you.
Thank you, sir.
Thank you for
Professor Pal. Thank you so much.
Thank you, this entire school, for inviting me.
Thank you, sir. Thank you so much.
Good to see a lot of people there from their different teachers, particularly. Of course, I had seen Apala earlier, so it was good to meet her again. And of course, I thank all the participants who are very keen and very good. And I have given similar things in National Science Talent Search or JBNSTS, Jagdish Bose, also very, very young, good young people, class 11. They get motivated. I'm sure many of them may be knowing about JBNSTS, or they will be giving exams. So I think I enjoy talking to these bright kids. Some of them will go to IITs, I'm sure. Some of them will go to medical. Some of them will come to science. That's how life is. If everybody, I always tell that, if all people do the same thing, life will become so boring. So there's a very famous poem which talks about the river, that different type river at the banks, the river in the middle, how they are all different, and everything is contributing to that flow. So I mean, all of you have read that very famous poem. So I think it depends on. So if you look at the Ganges itself, I think Ganges is black. Yeah.
Hope to meet you someday.
Yes. So I said Ganges is a life. The river Ganges flowing. So I think life is like that. So you keep meeting, you interacting, and it was very nice that I came here. Okay, thank you. And of course,
thank you so much, sir.
Jayasri Das Sarma enabled me to come here. Thanks.
Thank you, Professor Pal, for accepting their invitation. I know how busy you are, taking your time within your busy schedule.
Yeah, because 5 o'clock I had a meeting. So I thought that, but then now it became very late. By the time your lecture was over, it was close to 5.
Yeah.
So I realized.
Thank you so much. Okay. Sir. Thank you.
Anyway, Jayasri is there. She will answer questions on my behalf.
Sure, sir. Sure. Thank you so much.
Thank you.
Thank you.
Thank you, sir.
Over to you. Please place your question.
Yes. So my question is to Apala ma'am. I know her very well. She is my former principal also. She showed the presentation where for that pharmacology or for a new drug, she said that we will plan an objective, then we will do novel research on the chemical. So if I tend for a new disease like COVID, I will start to find a new drug which may be effective here. Or for example, I have a known drugs. We have those gliptins for diabetes. So if I want to develop a new drug which may be more effective or may prove to be less costly than one is present there, so how to identify that molecule? How to know that it may be effective?
So, yes, Abhinav, thank you so much. Very good. You have noticed that what I have said. So, I have presented a slide on drug discovery and the different steps. Okay. So, normally a new medicine will come by completing 9 stages. Okay. First of all, you have to the researcher. Okay, you are the researcher, so you have a team. You cannot do alone. You have a team, your research guide, then your our co-researchers, all will be there. Now your thinking is that you will be discovering, and the other is that modifying. These two are the different area. If you come to discovery, then simply you have to think first that which is the main chemical, novel chemical, which will affect that insulin part in diabetes. Okay, for whom this diabetes is there, and we can restrict that. First of all, you have to identify that chemicals that is called as a novel chemical. Now, when you are selecting that chemical, now you have to synthesize that one. You have to synthesis. Then you have to find out that which groups we are attaching to that benzene ring. Whether it is benzene ring, whether it is naphthalene ring, whether it is anthracene ring, whatever may be. So then you have to find out that functional group, and the functional group will be associated, and then the techniques, these stages. Suppose it is nitration is required. So acetylation is required. What is required? Then you are preparing first that your novel chemicals first. Now the novel chemicals, now you have to apply into that animal body first. Why animal body? Because whether this is affecting properly or not the efficiency, it is called the efficiency and safety. After that, then you are coming into that the healthy human being who is not patient. So when you are giving that healthy human being, then you have to observe that what is the effect. If you see that no, it is positive, then you phase wise 3 phases you have to give it to the patient. Patient 1, patient 2, patient 3. Then your clinical test will over. Now the drug you have to apply to the government body for approval or international body for the approval. Okay, when you are getting approval, then your production, then it will come into the market. And another one system is as the coronavirus, that vaccine and medicine, how that that repurposed drug. Repurposed drug means repositioning, means you are changing the position of any functional group. That is very easy. So which will also effective for the human body or the patient. Okay, for the recovery. So in that way, you have to come into research. So drug discovery is not so easy in that way. You have to be into, but it is, if you have that means affection towards that, please go into that.
Thank you so much, ma'am. The next one, yes, ma'am. Thank you so much. The next and the last question is from Argyodipto Kole from Birla High School, Kolkata. So Argyodipto, if you're there, you can please
Yes, ma'am.
unmute yourself
Ma'am,
and place your question.
Ma'am, I am on Cryptocol of Birla High School. Ma'am, currently studying in class 12. So, ma'am, today the question which I wanted to place to you is that using means we have seen a nanobiotic can be used in lots of means fields which are both for medical as well as for engineering purposes. So, ma'am, recently we have seen that the pig heart was transferred into human being successfully, and that the human being is still alive and he's functioning normally. So, ma'am, I wanted to say that using nanobiotic can we make such an artificial heart which can be is more efficient than a human being's normal heart. That means it will not fail suddenly, and that it can be also acceptable by such immune depressed patients and will not be disregarded by the body such that they might have a chance to die and collapse because of implementation of such type of tech in their body.
So I think we would request Jayasri ma'am to answer this question.
Yes, I think Jayasri ma'am.
Thank you. It's a very interesting question. But you have to understand that, yes, that is called nanobiotechnology and engineering. It is also required lots of immune system to be controlled. So first of all, immune suppression patient, people can do that. But for that type of hard to work, it is hugely time consuming and expensive. So that's what, of course, it made a success, and people can use it in a ultimate requirement. When there is because think about it, our immune system, we require it to combat with any pathogen, bacteria, fungus, viruses. So if it is immune suppressed, then placing the heart may function, but they may not have much sterile system to fight with the pathogens. In that case, the type of sterility we require, it is very difficult to countries like India, China, like this type of places. So yes, it made a success, and nanobiotechnology can made an evolution, but we have to think about the feasibility, as well as in 1 or 2 patients it may work, but 3rd and 4th it may not work because there will be immune rejection. So to remove the entire immune system is not a good idea. And one thing, it is my personal opinion, I don't know whether I should say in a public media, but as it is a very friendly thing and students should know, what do you want in our life? Do you want the life, which is non-functional, just to keep breathing and taking food like that, or we want a quality life? That's my question to the younger generations. We have to understand that yes, there are emotional thing, somebody in the family is sick, but we have to see where is the balance we should make. Like today, due to the advancement of medicine and advancement of this technology, we can replace the brain also. I have seen aneurysm patient, they open the skull and the brain mass is outside. But think about it, the trauma or the stress is going to the body, it is causing several other diseases, which is difficult. So it is like a compromised life. So that's what we have to understand, that yes, with the advancement of the science, we can do anything, but we should not try to control everything in our hand. Then one day will come, we will lost our control, like it happened during COVID. Like we were just going through the crowd. We didn't pay attention to our personal hygiene, our food habits. We didn't think about any restriction. But see, then when COVID came, so much science, so much scientists, so much medical doctors, so many people are together, nothing happened because this is a nature's call. So I think we have to respect our own system and respect the nature's way, how it is made, so we can have a quality life. That much I can tell you.
Thank you so much, ma'am. Over to Rashmi. Of course, there are quite a few students and they want to ask more questions, but it's already...
No, I think, Vijayalakshmi madam, the students, they have to ask the question. It is quite natural, but you gather that question and definitely will answer later on because the time will not permit. Students,
Sure,
you give the question, no
Yes,
problem, and we'll definitely answer those questions.
Sure, ma'am. Sure, ma'am. Rashmila, ma'am, over to you.
Thank you, ma'am. So
Excuse me,
first and foremost, we would like to show our gratitude to our keynote speakers, Professor Sourav Pal, Mrs. Apala Chakraborty, and Dr. Jayasri Das Sarma, and for the time that they took from their busy schedules and presented such an informative national webinar, which obviously stretched a bit more than the time that we were expecting. Today, we all had an amazing opportunity to hear your thoughts, and I'm sure that the audience has learned about prospects of chemical and biological sciences in research. On behalf of Asian International School, I would also like to take this opportunity to show our gratitude to the students, principals, and teachers who registered from schools across the country. We would also like to thank our Honorable Chairman, Sir, esteemed Director, Sir, respected Principal, Ma'am, Reverend Headmistress, Ma'am, the coordinators, and our IT team who guided and created such a successful event for us that added value and knowledge to everyone present. And a warm thank you to all the students who asked such amazing questions, who were there throughout this event. So this concludes our webinar. Thank you again so much. Have a wonderful rest of the evening and a fabulous weekend ahead. Take care.
Thank you so much, ma'am. Thank you, dignitaries. Thank you so much.
Thank you for giving us a chance. And it's really...
Thank you so much. Jayasri also.
Thank you, Apala.
Okay. Nice to meet you. Once again, we'll meet definitely. Okay, bye-bye.
Thank you so much, ma'am. Thank you so much.
Thank you all.
Thank you so much, ma'am.
And thank you all.